pitch trials that we have in different countries of Europe. Later I will talk about chilling requirements for normal production, methods to estimate these chilling requirements. About this, I'm going to talk about the spring frost days, how do they change, you know, this is also very important nowadays. How temperature and rainfall during blooming or fruit growth may affect and how has this changed during the last years. And lastly, and very important, mitigation. It's important to talk about mitigation measures that need to be taken. So, the first subject, although most of you know about this, but I find it appropriate to say a few words, that peach trees, like every temperate fruit species, require dormancy. They have a dormancy to escape spring, winter, low temperatures. They have evolved a mechanism that after short days and low temperatures, that is measured as a chilling requirements. Later, they will inherit later heat requirements. They will get long days. They will sprout. This mechanism is dependent on the genes that involved during this period. Chilling and heat requirements are parameters affected by climate change and are very vital for the peach tree flowering and fruit production. What we know is that chilling requirements usually are, when they are reached, then we measure the heat requirements. However, we know that in some cultivars we may have a chill heat overlap. What is happening in warm locations? In warm locations, as you can see on the left, chilling is not adequate. This will result in delayed bud break because the buds, the chilling requirements on a tree are not the same and depend on whether they are on the upper part of the canopy or lower part of the canopy, or whether the tree is vigorous or not, which means that some buds have more chilling requirements and they will bloom later. And if there is no chilling at all, we may have no bud break at all. Another important thing is that we have the formation of buds during development that result in deformed flowers. That is what we usually say to our growers. During blooming and when we think that everything is okay, it is good to take a sample of 30 flowers and to check whether these have fully deformed and well-deformed flowers, so that they know what is happening. I think it is one of the first initiative symptoms. We may have prolonged blooming, resulting in fruits in different sizes that do not allow proper horticultural management. And of course, we have low yield. And also, in some cultivars, it may be more pronounced to have deformed fruit. This picture here shows how the size, the shape of the fruit changes depending on how chilly it was. We have elongated fruit with protruding tips, and this effect depends on the cultivar. How climate has affected chilling accumulation. On the left bar, you may see what is the change in the chilling portions. Chilling portions is a measure of chilling requirements. The more yellow and red is, the higher the reduction in chilling requirements. That it was measured in 2000, on the first picture, and on the mid-21st century, and how it is projected. It is a very nice study by Ludwig in 2011. And you may see that the red lines, the warmest part producing area, that is the southern of the United States, that is the Mediterranean area, that is the southern America, are the ones most affected. And when we see red color, that is -20 and -30 chilling portions. We'll see later that this is a big number to happen. Examples where reduced chilling accumulation has studies that reduced chilling accumulation has already registered and influenced blooming and yielding peats in warm areas. You may see here that one's in the southern region of Brazil and another in Tunisia, in a study again by Ludwig in 2020, where it was shown that in some regions there is not going to be any peach production at all, or unless there are cultivars with only 10 chilling portions, which is a very, very low number. It was described very dramatic. The change was described very dramatic. What's happening in cold climatic regions? In cooler regions, there will be either an increase or no change in chilling accumulation. That is because they will have reduced sub-zero temperatures that does not add to chilling. Which means that in these places, since the chilling requirement will still be fulfilled, they will have increased heat accumulation that will result in earlier blooming and leafing. The earlier blooming, however, is related with higher risk of frost damages caused by warm spells that are happening. Therefore, high chill cultivars are needed with high chilling requirements, high heat requirements that I will explain later. Here is an example of a study from 2020 in the Republic of Korea, being in a cooler area where heat accumulation was related with blooming days during a long period where it was studied in 15 peach cultivars that they were, and they concluded that chilling is not a threat to peach production in this cooler region. Now I will move about the European regions, and this picture here shows the chilling requirements in peach cultivars could be from 10 to 100, which are the yellow and red. So the places in the graphs where blue is the color are the ones that will have safe winter chilling. The Mediterranean area is one of those with a higher risk. And here I would like to present you some of the new, just analyzed data from our EU-free trials that are made in 18 peach cultivars located in 11 sites in 5 European countries: Spain, Italy, France, Greece, and Romania, as you may see on the graph. These sites differ in the northern and southern latitude, as you may see there, and it goes from the west to the east. The trials are located in contrasting longitude that may exhibit pronounced difference in meteorological condition parameters, and also we expect the year-to-year variation to be also a parameter that will be important for us. We consider this as an important tool to study the influence of climatic conditions in the peach phenological stages and predict climate change effects. This table shows during October, the beginning of October was the time when we started measuring chilling accumulation until the end of February. You may see that in Bucharest and Cuneo are the sites where chilling accumulation starts earlier, whereas it follows Tebano in Italy, Forlì in Italy, Lleida and Zaragoza in Spain, and Bellegarde in France. It is later the 15th of November in Nausa and Rome, the times where we have the highest zinc accumulation, whereas the two sites in Murcia have got the least. Taking the mean of these 3 years that this study was made, it came out that the two sites in Murcia had 40 to 45 zinc portions, Nausa and Rome, Nausa 69, and it went up to 98 and 97 in Bucharest and Cuneo. There is a variation in the time of zinc accumulation and total amount. And on the right, you may see what we found when we estimated the zinc requirements in 14 from the 18 cultivars that were used in this study. It is the result of the Tabuenka test that was made in Nausa and in Leyda at the same time. You may see that for some cultivars in red, that is Katerina and Henry, zinc requirement can be up to 69, and in 2020, which was the warmest year, we had less in Nausa. And also Rome was not fully covered. When we measure the dates of dormancy release, you may see that during the warm year of 2020, dormancy release was by the end of February in Nausa, and it was not met in many cultivars in Murcia. Dormancy release was earliest in Bucharest and Cuneo, from mid-December to mid-January, although the start of blooming was the latest, by the end of March, suggesting that in these environments, the accumulation had a strong influence on the regulation of blooming time. Rest completion was instead latest or never reached in Murcia. Although blooming was earliest in mid-cold regions of Leyda in Spain and Bellegarde, France, and latest in the warmest location, Rome, and latest in the warmest location of Rome and Nausa, suggesting that blooming time is strongly influenced by the delay in achieving rest completion in Nausa and Rome. I think that was something, an important point to realize that this is happening in our site. And now talking about Nausa, which is, it appears to be a sensitive area to climate change. Here on the left graph, you may see how the temperature changed since 1964, and it was 1988 that the year where the change occurred, and with higher temperature, with a mean of 1.3 degrees Celsius, occurring mainly in January, June, July, and August. And on the right graph, you will see the chilling portions, how do they change, and it is important to see that we have the 12.2 chilling portions reduction during 1966 and 2022. Now we move to the methods of estimating the chilling requirements. Chilling requirements, I think, is a very important trait to know and to suggest to know before we collect the cultivar to grow in one site. So how do we measure this, and whether this is whether this is accurate or not? You may see here from the work from Yamain some photos showing that usually we do the Tabuenka test, where we cut sticks, branches, and then we, from the field when chilling has been achieved in specific times, and then it was moved to a room, to a hot, warm, to a city room. And then we calculate from when the rest completion was occurred, when is the chilling in the field. There are other methods, like statistical methods, where but you have to have a matrix of a long period, more than 16 days, 16 years of blooming, and you can relate the chilling accumulation during different periods during the winter and the spring period with the time of blooming. And you may see on the top left a method described from Ludwig PLR that is supposed to be very, has shown very good fit for many places. And in this method, you can estimate whether you have a ceiling, a heat requirement overlap. That is very important. And other graphs where it shows that where temperature is used in the matrix and that stuff. There are also other methods recently published using an electronic nose that is attached to a pitch flower patch, where the volatile emission is related with battery dormancy. There are different methods for quantifying chilling accumulation. It is, for no doubt, the dynamic model that is best fit in warm and cool climatic conditions. I don't want to say too much about this. What we found also in our studies to have less variation among years and to better describe the differences between cultivars that are assessed for the chilling requirements. We wanted to know whether the stability of results from the Tabuenca test went down in different pedoclimatic conditions. So we have the Tabuenca test made in IRTA and here in Nausa, and here you can see the p-value of the cultivar effect is non-significant. It is the fact that Leda and Nausa do not have that extreme weather conditions. Perhaps we could if somebody would like to join, it would be good to perform the same in more extreme conditions to see whether there is an effect on this. But that is a good result, but we don't have any difference here. Also, we wanted to know what's the effectiveness of the Tabuenca test to predict blooming days in different pedoclimatic conditions. For example, if we get that Katerina has got 70 chilling portions, and we use it in Cuneo or in for different cultivars. If you get if it is good in predicting those days. So we had 3 years, 9 cultivars, and 11 sites where we used the chilling portions that I showed you before, that was found from the Tabuenca test made later in Nausa, and we used those ones to predict what would be the blooming time during 3 years in all of these 11 sites. It was found that the prediction was different among cultivars. It was Sweet Green, Elegant Lady, and Big Top, the ones with a higher prediction rate. And you may see that the R value is about 0.7, which is lower to what has been found in other studies, but in other studies it was made in one location. This is tested in different locations. And also it was found the low effectiveness in the low chill cultivars. Perhaps the high effectiveness in Sweet Green, Elegant Lady, Big Top may suggest for better adaptability for those cultivars across different environments. Or perhaps in the cultivars that there is low adaptability, perhaps the Tabuenca test has not been appropriate, and perhaps there is an overlap between chilling and heat requirements that we can find about it when we have more years of data and we use the method, the PLR method described before from Ludwig. So we have more to do, I think. There is another similar study made in Japan, where it made on 5 only cultivars, where they also found similar results. Is it time? Do you have
okay.
Oh, okay. So what are the changes? Here is a map that shows how species are related to other fruit species. There is a big variation among cultivars. There are not that many studies that show the chilling requirements with the Tabuenca test. Here we can show you results from the chilling requirements in 51 commercial peach cultivars grown in our area. You may see that there is a variation, and the variation that is from 43 to 69, and what are the chilling, the high and the low chilling cultivars. In 2020, chilling accumulation was marginal for some peach and nectar cultivars. You may see there. About spring frost days, you from Italy and from France, you had a bad experience this year for our area in having this strong frost in April. On the left, you may see how the number of spring frost in March are occurring in Nausea during during 1994 to 2018. There is a decrease in the number of spring frost. However, this may relate with where you are. Maritime and coastal areas in Europe are supposed to be exposed to increasing occurrence of frosts. The invasion of polar air into Central and Southern Europe can create devastating frost damages, and we need to consider this in the future. Temperature and rainfall during blooming. We know that the first 30 days after full bloom, it was shown from the University of California very well in many studies, are very crucial for the temperature. The higher temperature means smaller sizes and shorter, earlier maturing time. Higher summer temperature may also affect the peach fruit skin coloring, increase sugars, and reduce durability. So we need to consider all of this as parameters affecting fruit. We have also seen that only a 4 days